So now what we have left to do is figure out how to find the probability of z being between two values. And if we think about that for a moment, let's draw a picture for that. So if we have a picture like this, okay, and I have an A here somewhere and a B here somewhere, and I want to know the probability that z is between those two, I want this area right in here. And we might recognize that that area is actually equal to the area to the left of B, which would look something like this. Here's B. And so if we take the area to the left of B and subtract the area to the left of A, which is right here, if we take this area minus this little area, then we get this piece right here. Okay, and so actually we can then use these pictures to guide us to our formula for doing this. This is the probability that z is between A and B, so z greater than or equal to A, less than or equal to B. And that's equal to the probability that z is less than or equal to B minus the probability that z, and let's use a capital Z here for consistency as I've been doing, is less than or equal to A. Okay, so that's actually our formula that we can use for finding the probability. So notice when we do this, the probability that z is less than b, this area is clearly larger than this. We want to take our larger minus our smaller, giving us a positive result. Probabilities should always be positive, and in fact they're always between 0 and 1. So let's look at a specific example for this. Let's suppose we want to find the probability that z is between negative 1.528, negative 1.58 is less than or equal to z, less than or equal to 0.82. Okay, so let's do this with the picture first, and then we'll do it using the formula. So if we look at the picture, we have a picture something like this. Negative 1.58 is going to be over here somewhere, negative 1.58. And 0.82 is somewhere to the right of 0. Let's put 0 in there. So here's our 0.82. And what we're looking for is the probability of being between those two values. Okay, so if we go straight to the table and look up 0.82, what that's going to give us is that's going to give us this probability, the probability that we're to the left of 0.82. So here's 0.82, and that'll tell us the probability of being over here somewhere. So if we look that up in the table, and here's 0.8, I think we can even see the whole table this time. So there's 0.8, and up at the top here, here's our 0.02 for our hundredths place. We get 0.7939. Okay, so this area is, so I'll write area equals 0.7939. Now if we go and do the same thing for our other value, the negative 1.58, it's over here somewhere, negative 1.58. And if we use the table, remember the table always gives us the value to the left of that z. So this one, when we look down here, we've got negative 1.5 here, and going across, here's the column below h right here. So we have 0.0571. Let me make sure I'm in the right row still. Yes, that looks correct. 0.0571. So that's this area. So the area that we're looking for is this larger area minus the smaller area. So our probability then is 0.7939 minus 0.0571. And let's see if I calculated that one. Yes, I've got 0.7368 or 73.68%. Okay, so that's using the pictures and our intuition to see what's going on. Let's redo the same thing with the formula. So again, we have the probability that z is between negative 1.58 and, whoops, let's get rid of that, put it in inequality, 0.82. Okay, and what that is that's our probability that z is less than the larger of those two numbers minus the probability that z is less than or equal to the smaller of the two numbers. And of course, again, let's reiterate the reason we like expressions like these two are those are probabilities we find directly from the table. So we looked these up already. Again, this one, the probability that z is less than 0.82 is 0.7939. And the probability that z is less than or equal to negative 1.58 is 0.0571. And the difference is then 0.7368 or 73.68%. Okay, so let's have you do one. So the one I've picked out for you to do is, let's try this one. Let's look for the probability that z is between negative 2.19 and negative 0.33. Okay, so again, take a few minutes to work on that. Pause the video, and when you start the video back up, I will go over the solution. This, again, this is a minus sign right here. Okay, so let's use the formula this time first. So the formula, remember, is we find the probability that z is less than or equal to the larger of our two values, which is always this one over here when we arrange things in this order. Negative 0.33, even though it's negative, is still larger than negative 2.19. So we have the probability that z is less than negative 0.33 minus the probability that z is less than or equal to negative 2.19. Okay, so looking those up on the table, the probability that z is less than or equal to negative 0.33 is 0.3707. Look that up again if that's not the value you got. Pause the recording and look again. The probability that z is less than or equal to negative 2.19 is 0.0143. And subtracting those two, we get 0.3564 or 35.64%. We might take a look at a picture and see if that seems reasonable. The picture in this case would be something like this. Here's 0. Negative 0.33 would be just a little bit to the left of 0, and negative 2.19 would be quite a bit out here. So it would look something like this. We know that the area to the left of this dotted line, or dashed line, is 50%, and so it would seem reasonable that this shaded area might be 35.64%. Again, you can look at the same problem in terms of areas. Okay, so let's just use this picture again. You could look up on the table. You could find the area that's to the left of negative 0.33. Okay, so you look and find this area here, and what you find is that this area is 0.3707. And then we also find the area to the left of negative 2.19. So that's clear over here somewhere, negative 2.19. That's going to be a fairly small area. We look that one up and we find that the area is 0.0143. That's about 1.5% there. And then we can see that the area we want up here, this area, is this one minus this one here. So we have 0.3707 minus 0.0143 equals 0.3564. which is 35.64%. So that concludes our lesson for finding areas under the the standard normal distribution. Actually, let's conclude by just kind of summarizing the three cases that we run into. So the first case, so these are the cases that we can see. The first case is that we want the probability that z is less than or equal to some value a. And to do this, we just get this value directly from the table. The second thing we want is we might want to find the probability that z is greater than or equal to some a. And remember, this is all the rest of the probability that remains after you take this out. So this is 1 minus the probability that z is less than or equal to a. And so that's our formula for doing this kind of thing. And then we want to find the probability that z is between two values, a and b. And remember, that's the probability that z is less than or equal to the larger value, b, minus the probability that z is less than or equal to the smaller value, a. And that's our formula for that. And those are the only three possibilities that we'll ever see when we're finding probabilities from normal distributions. So that concludes our lesson on this. In the next lesson, we'll go on and work with actual data sets to find probabilities based on those data sets for normally distributed data.